Hey, great. Thank you everybody for coming. Today, or right now, we have the first of three sessions for this winter meeting on marine data, where these sessions have been organized and put on together by the Marine Data Cluster, Semantic Harmonization Cluster, Semantic Technologies Committee, and the Schema.org cluster. And the first one is towards digital federations for marine data for societal benefit, trust, pluralism, and multilateralism during the UN Ocean Decade. So what else is happening within ESIP and the Ocean Decade? How can these be connected? We are not using Slido for the first two sessions. So if you have any questions, comments, notes that you want to put down, just please add them to the document. You can easily find it through the link or through Chico chat, and then we can discuss more in session 3. Where we have time explicitly built out for this. We will also have some discussion time at the end of the session. And so our roadmap, what are we discussing today? We'll start out with a brief overview of what happened at the 2023 Summer ESIP meeting during a session led by the Marine Data Cluster. We'll go a little bit more into the sessions we have for you this week. And then we have some discussion prompts and ongoing discussion about federated data, building more trust in marine data. And so in the 2023 Summer ESIP session, it was titled ESIP and the Ocean Decade, Efforts and Opportunities to Engage. We had a brief introduction by Steve Diggs on the introduction to the Ocean Decade. We covered a couple of projects by Frank Mueller-Karger on Marine Life 2030, Kate Rose talking about CMAX. And then we broke out into groups. We tried to come up with ideas and then follow up. And so following a vibrant discussion on ESIP's unique contributions, we organized an unconference to sustain the momentum. Recognizing the need to foster collaboration, we facilitated cross-cluster calls between the Marine Data Cluster and the Semantic Harmonization Cluster. This journey culminated in sessions at the January ESIP meeting, bringing us to our current endeavor right now. And so today we build upon the foundations laid last summer, aiming to transform ideas into actionable outcomes. Our 3 planned sessions revolve around the intricate concept of trust within data networks, particularly the Ocean Decade's objectives. This introductory session provides an overview of the landscape and key players. The subsequent panel discussion delves deeper into the diverse perspectives on trust, promising a fascinating exploration. Finally, our 3rd session focuses on practical solutions, featuring discussions on hosting deep ocean data, available tools, and a brainstorming activity aimed at bringing more federation and trust to ocean data. We invite you to join us on this journey of exploration, discussion, and collaboration. And so here are the 3 sessions that we have for you this week. We hope that you will stick around for all of them. And so here we have our presenters. We'll start off with Adam Shepard talking about SOSO. And so all of their bios can be found online in the notes. If you're interested in looking to learn more about our speakers, please go there. Otherwise, I will turn it over to Adam right now.
Welcome, everyone. How are you doing today? Let me get my screen share going. How's that look? Is that good for everybody?
Yeah, it's good. It looks like a browser or something. Like from slideshow mode.
Oh yeah, let me do that. Presenter mode. Let's see. Is that better?
Yeah, that's better.
Okay, great. Thanks, friends. Well, I'm here to talk about SOSO, which is an acronym for Science on Schema.org. Schema.org has been talked about in ESIP for, gosh, a long time, at least 10 years. So it's been out there. But I think adoption of it and really seeing its capability has just been a recent endeavor, maybe the past 5 years. So because of that, I'd like to just start with what is schema.org. So here's a big slide asking that exact question with no other purpose but to prompt you. All right. So I think what I'd like to do, and just trying to describe what schema.org is to start with one of these rich snippets off of the Google search engine. And I think it's really critical to think about the end result and what's possible here to really understand the utility and the reasons why adopting schema.org might be useful to you. So what we're looking at is a description of the Wyndham Grand Pittsburgh Hotel. And we're seeing all these buttons and information that's broken out into a really nice, neat, organized way. And so I think before schema.org existed, search engines would go out and harvest this information based off of the HTML markup and do its best to try and present a reasonable result. But what's interesting here is that schema.org is something, a technology or a technique of publishing data on the web that enables a little bit more fine-grained description of what your content on a particular web page is about. And so I wanted to highlight certain things here. So like a title of a web page, right? No big deal. A button that clicks off to the website URL, no big deal. But then there's some more interesting content, like a structured address or a phone number that is clickable. And then even on the right-hand side, some features about that hotel with icons. And so we're seeing this result at Google be a little bit more interesting than what might be possible by just reading your traditional HTML. And so schema.org is a type of data markup that goes inside the web page. And there's some schema.org generators out there that will help you describe that content in a very structured and atomized way so that you can specify exactly what's the fax number, what's the email address, what amenities does your hotel have. And so it's this record that we'll look at in a second that builds out this information in a structured way so that harvesters like search engines can understand what that content is and display it in a more rich style. All right. And so the schema.org business, what is it? Well, actually, it's a vocabulary describing things like a hotel. And so here we're looking at a web page on the schema.org website describing what the hotel is. An inset is the RDF vocabulary that describes what this hotel is. And so we can see that it's some type of class or classification, if you will, within this vocabulary. And that interestingly, that there's subclasses under hotel for things called like a lodging business. And so what schema.org is a structured vocabulary describing things that we as web publishers can then apply to the content of our web pages. And so I want to focus on that part next. But before we get to that, I kind of want to give you why I think it's important to go through that little bit of effort to describe the content of that web pages. And that's because the page content is about things that you care about. And this schema.org vocabulary is a schema that's agreed upon by the publishers of those web pages. So us, maybe we're data repositories, maybe we're just a research project. We're the publishers of that content, and then the downstream consumers, and that might be search engines. That they're certainly the big heavy consumers, but it might be other entities, as you'll see later today. So it's an agreement between those publishers of web data and the consumers of that web data. And this is the really key thing, and that's for making that content actionable. And I want to drive that home. Like, what is actionable content? This is the whole point of adopting something like schema.org. So if we go back to that web page, what's actionable is, interestingly, we can click on a map and get directions to it. We can click the phone number and make a phone call. We can click that check availability button and actually see what rooms are available during a certain date. And so this is really key. You know, what that web page is describing is geospatial information, telephone information, but also it's accessing some type of data service. And this really brings up interesting questions when we think about research projects in the sciences, and then more specifically data sets. And so what does this mean for science data? What is actions in the science data community? What do our data consumers really want for actions when we're thinking about actionable content? And it's very similar to what we saw with the hotel, like mapping it. I don't know if we necessarily want to get directions to it, but we want to know where it is. We might want to download it, graph that data, but there's other things. And so this effort called SOSO, or scienceonschema.org, was an avenue for us as science data publishers to come together and really mirror all the work that we do in metadata right now. So DOIs, ISO metadata, EML, whatever that is, and marry that with efforts in the schema.org space in this web publishing practice. And so, you know, the vocabulary schema.org is already out there. Why do we exist? What's the need for science? Well, really, it's just a way to communicate more specifically to our geosciences domain about how to adopt the vocabulary, so that you don't have to go there to the schema.org vocabulary and make all these decisions on your own. We can give you essentially guidelines as to how to make decisions about what this content means and how it was meant to be, or how it could be adopted commonly across our community. And so if you go to the schema.org page, what you're going to see is flat descriptions of this vocabulary. So it's really hard to decipher where to navigate and how you navigate through a data set, for example. The examples of how to adopt it are very limited. And there's endless ways to publish. There's so many different fields. And so the guidelines here are for our community to sort of share those common publishing patterns in a reliable and consistent way. And by doing so, we almost build this federation simply by following the guidelines in-house. We sort of align ourselves to all these other communities that are doing the same thing. And you'll see the impacts of that in a little later talk. Okay, so our guidelines, what's different? Well, we don't have flat descriptions, but we have drawings that draw out sort of like the connections between those things in the vocabulary. And we've got coding examples, so you can see how to do it in a way that makes sense to the harvesters. We also just recently did a tutorial. I don't know if it's recently, maybe 2022. And you can get to that tutorial through this bit.ly link. I think there's 18 different lessons that walk you through learning the coding style of JSON LD, which is the format that is preferred, and how you might apply that to the data set concepts. Our latest release is a 1.31. 1.3 release was endorsed by ESIP, which was a great endeavor for us, just sort of getting recognition that this is worthy of adopting. And so described on this web page here is just a little bit of what's involved in 1.3. We had a minor release just to fix some things, but all this content is published out Zenodo and gets a DOI for citation. And then finally, I just want to wrap up by saying you can get involved. The cluster meets every fourth Tuesday at 2:30. Honestly, I think the best way to get involved is probably just to jump into the GitHub issue queue, ask questions, hit us up on Slack or the mailing list. But that is a very brief primer into schema.org and actionable content on the web. So I'll end there and ask if we have any questions. All right. Like a good old bran muffin right in the morning here. Some schema.org for you.
Thanks, Adam. That was awesome. I just wanted to point out that Allison posted an article in the chat highlighting your work.
Great. Thank you.
Great. So next we have Pierre Luigi Brigig presenting on Otis.
Okay, so you should see a screen. Oh, you got that?
Yes, we see your screen.
Great. Okay, thanks. So this is an interesting case because, I've been working with ESIP semantic harmonization initially, but also wandering into other clusters over the years. And So in 2018, Sky Bristol and myself were invited over by the Intergovernmental Oceanographic Commission of UNESCO, so IOC, to help them draft a proposal for how the member states and other sort of major data hubs and minor data hubs in the ocean can more effectively share data and information. So the idea back then was, okay, let's build one big database. And Sky and I said, no, please don't do this, because we're moving to a distributed world and you just can't possibly keep all the data in one place anymore. So that went in, it got funded by the government of Flanders Kingdom of Belgium, and was executed by IODE, so the International Oceanographic Data and Information Exchange, which is the data wing of UNESCO. And over the years, we built it, we did it, right? And that was quite remarkable. Doug Phils, Jeff McKenna, Lucy Scott, the core team with myself, and many, many people have helped build this federation. And this came from, I mean, we were thinking about how do we implement this thing across all these different stakeholders. And the thinking from Science on Schema won out. I said, okay, let's do it this way. And so Otis and the Ocean Info Hub is taking that sort of core thinking from Science on Schema and applying it to this case in the UN oceans environment for the decade. So I'll just we'll start a little bit about the decade and then go quickly through what we did. And then Doug Phils will pick it up about the actual implementation architecture that's underneath it. So it'll be a bit of a whirlwind tour. So the UN decade, a lot of this change is being catalyzed by this UN Decade of Ocean Science for Sustainable Development. This is a call by the member states. It was endorsed by the UN General Assembly to basically transform the way that we relate to our oceans. And a big part of that is motivating governments and research organizations and others to take the chance, because everybody else is too, to try to do something a little bit differently. So in this environment, it's been really, really important to catalyze the work we're doing in Otis, so people think of the art of the possible, shall we say, with data too, not just with diplomacy. So, of course, the Ocean Decade was called to help us address the Sustainable Development Goals, the development agenda that the member states have signed off on, particularly SDG 14, Life Below Water. Early on, before the decade kicked off, an implementation plan was written. And in that implementation plan, there's a data section that myself and a few others co-authored. And we focused again in on distributed data, linked open data paradigms to try to get away from let's all keep our data in one database, because especially when people don't necessarily trust other nations in this world where multilateralism is declining in many cases, we have to build something where people can hold on to their data, exercise sovereign control over it, and share what they want when they want to. This applies to nation states, but it also applies to groups like indigenous peoples, who may not wish to share everything right away. It applies to scientists too, who have intellectual property concerns or crediting concerns. So being able to scale one's participation is important. And that's also why Science on Schema and the metadata level that schema.org provides is so important, because you don't have to share everything right away, but you can still announce that you have it. And if there's a negotiation that needs to be done, you can point to that. So the Ocean Decade is there. It's operated through decade actions and all for actionability. So these are some old figures, but there are certainly more programs, projects, contributions, and activities, all of those known as actions, which are multinational. There are major research organizations, corporate sector, governments involved, trying to figure out how to change things from biodiversity to deep sea ocean mapping to anything you can imagine, cultural changes, engaging the public, citizen science, etc. So there are a number of mechanisms the decade is using, the Ocean Decade is using to coordinate this growing community. It's not easy, but it is helping rally effort towards that transformative agenda. National decade committees are now up and running in many countries, more are on the way. The US has one for the Ocean Decade, but we have quite a few others that are popping up. The goal of these is to help the decade system understand the national and regional challenges that each one of the participating member states has, so we can calibrate the global action to better include everybody, regardless of their national and regional constraints. So in that whole framework, reporting ultimately to the UN General Assembly at the top, we have a data coordination group and a data strategy implementation group. So those were called to try to get a kind of central strategy and central implementation guidelines for the decade, again, listening to the input that we've had from the participants, the programs, etc., and trying to find that spot in the middle where we can have participation from around the world. So after that implementation plan, those bodies have written an Ocean Decade implementation strategy. And then we are writing currently the implementation plan that builds on that strategy at a lower level, saying, please do this. And part of that, please do this, is what you're about to see in Otis, which traces itself back to Science on Schema. So again, please share your metadata in an actionable way using a very neutral vocabulary that's out there. This is the group. It's co-chaired by myself and Kevin O'Brien from Goose over in the US, but we have a nice international team covering most regions, and we're reaching out to other regions to participate. So the whole point of the data strategy is to build and sort of mature the digital ecosystem that exists. So the digital ecosystem, it's socio-technical, lots of different kinds of technologies and lots of different kinds of people. We have one right away. The digital ecosystem is a trivial thing to build initially over the web, but we have to mature this into something a little bit more functional than it is so that people can interoperate and share data. The hard part is the socio bit, not so much the technology. It's convincing people to do things in similar ways that are interoperable. And that's actually what most of the work in Ocean Info Hub and Otis has been about. The whole point is to say that, okay, if you're querying a data source you're familiar with, if they don't have something, they need to be able to query other data sources around the world and assemble an answer back to you. But again, you can't expect somebody to know about all of those data sources. So we need to build the glue that allows data resources, be they large or small, to communicate with each other and say, yeah, I might have something to help that stakeholder. And the idea of a one-stop shop doesn't really work anymore. There is no such thing as a global one-stop shop. Just as there is no store that provides everything all the time, you need to create global supply chains to feed what to the user should feel like a one-stop shop, but the back end is more distributed. This has to work for different kinds of stakeholders that are out there because they want different user experiences, but they should be talking to the same architecture. So with those things in mind, that's what Otis and OIH were setting out to do, to create these digital supply chains, starting at that sort of metadata level with Science on Schema. We're almost done with the project. It winds up in June, but it won't stop there because Otis has now been accepted as a sub-program of the IODE. So IODE, because of the transformative nature of this work, has reconfigured its internal workings, and Otis is there to stay with some long-term support from the member states. That's good news. That allows us to then expand what we do as part of the core UN machinery, which is great. The whole point, again, is that we need this at a global scale, and we want this to be equitable. And we're talking about ethics or so. So part of this is to make sure that our implementation is close to the ethical goals that we have. We can't leave people behind, and we have to check against that function when we're considering our ethical considerations, that whatever we choose to do will not somehow exclude people as far as possible. So we developed this federation of partners around the world in order to do this, and also to cross-check us that what we're recommending is actually feasible and working with their all sorts of different implementations and communities. So that's it. Our mission, these goals I'm sure you've heard before, but again, in this UN context, we have access to very different sectors with different needs, and we're tuning our technology to those needs. And creating this federation with the internet is our hub. The internet is our exchange medium. To help these systems interoperate and build those supply chains. We also provide capacity building to regions and nations that don't have it in order for them to join the federation and to operate there independently. So, that was the original figure in the plan. All of these different systems, UN systems and external systems, can start to share things over a global linked open data universe, and then create whatever kind of user experience and interface they want. We started in regions that are often left out of, let's say, the big ideas, so not the global north necessarily, in order to make sure it works for them. And that's another reason that the schema.org route was chosen, because the market share and the fact that many businesses have structured data on the web means that most people can hire a contractor with the skill set to participate. We had just a small group, but our group has grown more and more. We're delivering, I think, an order of magnitude more in terms of partnership and data objects than we intended to, and they're all over the world. Once the partners are there, we can coordinate a whole number of different systems, from biodiversity systems to European projects to NSF-funded projects to decade programs like Marine Life that was presented last ESIP, biomolecular data, WIS2 from WMO, WESR from UN Environment. So it's also helping the UN system come a bit closer together with ocean data. Our core architecture sharing this stuff is just profiles of schema.org and JSON-LD as SOSO recommended. But as Adam said, we needed to create some more developed guidance for people to actually format their data, and that's what we did. We build it, we show implementation examples, and when a new stakeholder comes with a different need, we help them develop that. We're working with Kirsten on samples, a number of people with marine protected areas, instrumentation, etc. So of course, that all builds the knowledge graph, which you'll see a little bit later. So I just stole that from Adam as he was presenting, and that's the idea that we're creating those and documenting them in our book. So it's online. There's a link in the notes how to get to that book. So our documentation is there, and it's helping the world converge on similar usage to stabilize the ocean bit of the internet. When somebody needs a new Otis pattern, they just post on our tracker. We work with them on their metadata needs for hazards and disasters, for protected areas, you name it. Create it, publish it, and then help stabilize things. And as new needs arise or if problems are identified, we can modify that in a more flexible way. This is key. So inside that, things like keywords, this is where we can link off this graph to the work of semantic technologies, semantic harmonization. All of that work that's being done in those clusters can be nested in that generic high-level semantic framework of schema.org to make sure that precision is present and interoperability is present at that level. You can also do this in the variable measured, where things like the essential ocean variables can be nested and then linked off to the appropriate semantic resources that better qualify them. So this is really like a hub where all of these things come together. It's growing. Doug shared this image earlier today. So this is the map of ocean data as we can see it. And as time goes by, we're going to try to build this out one layer at a time so we have an automated reporting on the state of ocean data. And we can hopefully emulate that in different domains. When we gather that, as you said, it's as Adam said, it's actionable. We can build portals pretty easily because the data is structured. So all of that stuff can be gathered from all of our federated partners, seeing what kind of vessels they have, what documents they're sharing, what experts are there, what languages do they speak, institutions, spatial data, etc. And people can search for things like whales and query across all of our partners, so not just one. See where it is, go onto the map. If they provide you a spatial metadata, we know where they saw those whales, and they can filter based on any of those schema.org properties and anything else they nest in. This faceting is dynamic, depending on what data is actually there. And as people kind of link in, and the UK has been a big adopter of this, the density of that data increases remarkably. And I think we are updating our interface, as Doug will show, to accommodate that. But this is good news. It's really changing things quite a lot. We monitor this through a dashboard. So we can concretely monitor how our different nodes are sharing things, if they're operational, if they need some help, if something's broken. And I think that's really important for building trust. Functionality has to be protected. Trust, it requires that some kind of basic functions of exchange are being met. So we monitor that as the graph grows, as we fix issues that are there, and it's all available, again, online. I won't talk too much about that, but this was in a previous session with CDIF, the Cross-Domain Interoperability Framework, and the World Fair project in Europe, where we're scaling up and out. So we transferred a lot of what we've learned in Otis into the Cross-Domain Interoperability Framework testing for discovery so that we can take this away from the oceans and towards other domains. There are 11 different domains represented in World Fair, from nanomaterials to cultural heritage, etc., hazards and disasters. So we're hoping then that can federate it. There's a deliverable over there that describes how we do that and what our thoughts are on that process. So, of course, for that cross-domain interoperability in World Fair, we identified a number of areas, and many of them pick up on ESIP clusters. So I think there's a lot of potential there. And we're all moving this as the first layer of a data space with integration on demand, where people can just request whatever semantics and whatever serializations they need to do work, and so that we can get things moving more quickly. As I mentioned, we're working with WMO and UN Environment and other folks to try to link their digital ecosystems to the ocean one and gradually make this a seamless experience. But we need to build those supply trains. We need to do the plumbing, the work underneath it all for that to happen. So that's a summary. I've talked about it more or less. I think I'm out of time also, but I think I'll leave with this thought mostly, that this is an environment that really has a convergence of the work from SOSO, from the biological data cluster, discovery, of course, this is a discovery mechanism, disasters because of the UN environment and UNESCO goals, and of course, marine data. This is a chance for us to really basically harness the momentum of the UN Ocean Decade and get ESIP communities plugged in, self-sufficient, and part of this global initiative. So with that, I'll stop. Thanks.
Thank you, Pierre. Does anyone have any questions for him right now? If not, I will turn it over to Doug Phills, who will be talking more about Otis architecture and the data model. Thank you.
Doug, you're muted if you're talking. Still muted.
There I am. Thank you so much. So all you missed is that I'm Doug, and thanks for the opportunity to be here. I'm going to talk a little bit about the architecture that is behind what Pierluigi was talking about, and had mentioned this architecture leverages SOSO and the web architecture and things like that. And indeed, if you really want to think about the fundamental principles that we're talking about, this is web architecture, right? We're using the web, using HTML, JSON LD, HTTP, these kind of standards. This is, I think, key, especially as we scale this out, because then it is a commodity type environment. Semantics is along, of course, to give context to the various resources that we're talking about. And this is very much, as you'll see as we move down through this kind of whirlwind tour through the architecture, this is really kind of a resource-oriented architecture, trying our best to keep the approach very simple, very lightweight, moving objects around, trying to deal with them that way, so that you can have a range of organizations implementing this without a great deal of burden on the operations that we're working with. This little diagram just kind of gives you an idea of some of the personas that are involved, how I kind of think about it and break it down. We have the publishers of the information, the people who are actually expressing the JSON LD. These may be data repositories, or there may be places offering courses or things like that. There's the indexer, which is the software that comes along and collects this information and forms a knowledge graph out of it. This is really a commodity. There are multiple implementations of this. And is just, like I said, leveraging that web architecture to do that. And then you have that community that's utilizing these, that's working on the products that are coming out of these. And those people, the user community and the people who are actually trying to index it, are the ones who can influence that guidance, right? The profiles, the patterns and things like that, that the publishers then use to represent that information. So there's kind of this continuous flow. If this looks a little bit like a fair implementation network, that's fine. It's not intended to be a pedantic implementation of fair implementation networks, but I can see the alignment with that approach. So just to give you a very high level overview of the activity flow that takes place within the Ocean Info Hub. As mentioned, we have our partners. We have about 40 active partners and probably about a dozen more that we're in talks with, that are working towards publishing these resources on the web. They collaborate in the guidance documents. They publish those resources. We then have an architecture set up that is harvesting those resources. We use an object store behind the scenes to hold those particular resources. And then there are some operations that take place on those, and I'll talk a little bit more about those later, but really we're trying to validate those systems. And then there's some ETL processes that are generating products from those that are part of the interactions that we're having with different partners. And I'll detail all those out in the following slides. I did want to make one little note about provenance, right? So we do work with our providers to have them try and express provenance using schema.org in the JSON LD data graphs that they provide to us. And that's wonderful. We also use the W3C prov for the activity that takes place. So Gleaner is the software package that kind of came out of the NSF EarthCube work that does this. It's what we leverage in Ocean Info Hub to do this indexing. It generates W3C prov records of what's going on. Those are separate from the knowledge graph though. So in addition, I'll just mention, we do shackle validations on the records that we get. We don't yet integrate any provenance from those shackle records into the overall provenance that we have. When we generate the knowledge graph, though, we do not include any of the provenance from our activity into that knowledge graph, right? So the knowledge graph really is the product of the partners that are expressing their resources for the Ocean Info Hub. We use the activity and shackle provenance behind the scenes for kind of our own maintenance of that workflow and observations on that workflow. But we do keep provenance, and that's very important in that regard. Another thing that's really important, right, is validation. And so because we're operating in a graph space, we're leveraging shackle to do that validations. And so we create shackle shapes for the various patterns that we're expressing, and then use those to validate the resources that are coming from our partners. And then key to that is to generate a report from that, right? So currently we're automating this through GitHub Actions. We might move that to Dagster, which is the workflow engine that we use to actually do the harvesting for these for the system. And then the automatic generation of reports that we can send out to our partners, right? And so this is being able to give them a breakdown of, what were violations, what were warnings. We try to give a broad overview of that report so they can see how they're doing, and then a detailed list of the reports with individual URLs that are involved there. And again, very open about all this. It's all published at the GitHub repository. And again, this is really probably an element that can speak towards that trust aspect that's developing or as a theme of our discussions. One of the things we do then is that once we do that harvest of our partners, right, we formulate a knowledge graph, right, from that, right? We're taking all the JSON LD documents, we're creating a knowledge graph, and we can begin to explore various options or various approaches that we might be able to take with that. I'm not a graph analyst, but it's kind of fun to play like one sometimes. And so this graph that you see here is just looking at the type relationships between a subset, a very small subset of the OIH graph. In this case, I believe it's ocean best practices, ocean experts, and OBIS, the biodiversity system. And so this is just kind of talking about how we can build then, Pierluigi sometimes called a state of the ocean, right? This idea that as we're pulling in all these resources from the partners and forming this knowledge graph, it allows us to start then looking at the different types of relationships that exist between here. And this one's very interesting, right? Because it leverages ocean experts. And so then you see these clusters forming of the institutions, the people that are associated with the institutions, and as you work out the data sets or other types of objects that those particular people are associated with. So kind of a fun visual in that regard. Speaking of the knowledge graph, one of the things that we really wanted to do was make this a useful tool, a useful product for the community. So this is a work in progress, and it's not operational yet, but we're working on the process by which we can generate release graphs periodically for the community. And part of this was because this allows, if we, first off, setting this up in a triple store is difficult for us to scale because a triple store, especially when it's a large graph, takes a lot of resources, takes a lot of maintenance, and it might not even be performant, right, when you need it. And so one of the things that we're doing then is the concept of these release graphs. And so for each partner, periodically, we can formulate that graph together, publish it as an INQuad file or potentially a Parquet file, put it at the object store, and make it available for people to download and utilize locally, whether they want to do analytics with it, whether they want to use it for some kind of analysis or something like that. And also make that a citable resource, right? So now then this is a snapshot, it's immutable, and it's citable. That's actually one of the challenges that we have with this because, as Ocean Info Hub, this is not our product. This is a product of our partners, but even our partners in some cases are aggregating other groups. I spoke with CUs in Canada about this, talking about, hey, how are we going to do the citation of something like this? And they're like, well, don't cite us because it's not our information. And we're dealing even in some cases with, kind of First Nation groups within Canada, and the data is coming from them. That's really their information. And so there's this whole, provenance chain, but also citation chain that is really a challenge. And so if people have guidance on that, I'm all ears in terms of trying to figure out how we address that particular problem. These objects will be given DOIs, Zenodo made available for download over the web. This is the direction we're going towards, though, so that we can really kind of get an engagement with the work that we're doing. We also then have these data products that are coming out of this, right? So from the knowledge graph, what we're doing is kind of creating not only those releases, but also then working on a way to produce products that address functional goals within either within OIH or within partners that we have. And so, for example, we have a process by which we're querying the knowledge graph to generate the JSON files that feed into the Solr index that actually drives the front end search that you're seeing at searchoceaninfohub.org, right? And so that process of knowledge graph to product to JSON, we tried to do that because then it allows us to leverage that for generating other packages, right? Whether it's GeoJSON or geo packages. And in fact, the image you see here, as you saw previously, Pierluigi was showing some images that get very dense, right? Once you start putting all the geometries and things like that in there. So we worked up a pipeline that then leverages H3 grid cells. We could use S2 for our hierarchical discrete grid, but then finds the counts that are within each of those and then presents us more as a heat map type system. And so it really is this kind of, how can we make the generation of these products from the knowledge graph easier and easier. And then that brings us to the last slide, which is the slide of logos, which is really kind of carrying this whole thing out, right? The top graphic here spells us out coming from our partners with their source files through Gleaner into the object store, combined with the queries that we have to generate these data products, and then converting those into something that we can utilize in this case, and this at the end goal with this one, with WMO Wiz2 through GeoJSON, right? And so these are some of the partners that we're working with to, kind of exercise that Otis knowledge graph and generate these products that are coming from it. So this has been a whirlwind tour through the underlying architecture. But if you have any questions, happy to address them now or later. So thank you so much.
Okay, if there are no questions, we'll move on to Karen Stocks, talking about Deuce and deepening the ocean.
Thank you. Give me just a moment to get that slide up and share it. All right. Does that look all right? And do I sound okay?
You sound fine, but your slides have disappeared.
My slides have disappeared.
You're not sharing your screen anymore that I can tell.
Huh. Let me try sharing again. All right. Now, if I go into full screen slideshow, does that disappear?
It's fine now.
It's good now. Okay. So I'll be giving a somewhat less technical talk. Tomorrow, Doug and I will be talking about some of the technical implementation work we're doing around this. But my goal today is to tell you about some other work that the deep ocean community is doing to engage with the decade as an opportunity for people on the call to find connections and engage in as well. I am just the presenter for this work. It's being carried forward by quite a few other folks. I have them listed later. So this work came out of the Deep Ocean Observing Strategy, which is a GOOS project, the Global Ocean Observing System. It is also an Ocean Decade program, and it has been funded in the National Science Foundation as an ExcelNet project. It is bringing together different groups internationally that are involved in deep ocean observing in one way or another. This is everything from the observing networks themselves, individual scientists who are doing deep ocean research, the data and cyber infrastructure groups, modeling groups, as well as those that are working to take the science and apply it to management and policy decisions. So we're a community-driven international initiative looking to align the deep ocean observing community towards collective solutions-based science. We do that in a variety of ways, a lot of networking, a lot of facilitation, collaboration, building. We also have a very strong early career researcher engagement and mentoring program. So I'll now talk about one very, very small part of the many things that DEWS is doing. But if you're interested in the group in general, I've got the URL again at the end. So this past October, there was a workshop held by DEWS that brought together decade programs that were either completely deep ocean focused or partially deep ocean focused. And the goal was to collaboratively identify concrete objectives and milestones that could, the wording they use, increase the focus of the deep ocean in the ocean decade. I would also turn that around and say, identify how DEWS in the deep ocean community could most strongly contribute to the ocean decade work. What came out of that is a white paper. It is currently in draft, so I don't have a link to give you quite yet, but it will be ready and public before the Decade Conference in April. And what this does is lay out what they're calling cohesive asks for deepening the decade of ocean science and sustainable development. Many of these are not around data or cyber infrastructure. So I've got them listed at the end for reference, but I'll focus on just those that do have a data component. And I'd like to recognize Liz Hetherington, who really was the person who led this work, as well as Lisa Levin, who's the chair of this working group. So the report has a whole series of vision statements backed up by goals and specific targets. Here is an example that the deep sea is critical to planetary health and wealth. The deep ocean community goal around that is to contribute to mapping of the seafloor. You'll see they all have some words around why this is important and such. In later slides, I'll trim that out. And then they name specific targets. So for example, here to map 100% of the seafloor to modern standards by 2030. And it's important to note that this is collaborative work. We're very aware that Seabed 2030 has this as its goal. It's leading this work forward. So we're not looking to compete with or work orthogonal to. Instead, we're saying as a deep ocean community, this is something we feel that we can contribute to and plan to. So another statement is that the deep sea ecosystem function depends on biodiversity. So there's a goal here to monitor biodiversity for conservation and management of the deep sea. And there's a specific focus on eDNA technologies and contributing to databases, ensuring that all deep sea ecosystems have representation in eDNA databases by 2030. Again, not looking to recreate cyber infrastructure ourselves. And then there are a set of other targets that have less of a data focus. The deep sea data are a world heritage. So this vision statement is focused specifically on data. And the goal here is to promote fair, open science and care principles worldwide. We plan to provide, which really means offer, fair and care data training to all of the decade endorsed deep sea actions by 2025. Some of them are well on their way to understanding this as well, but others we have a role we think of education. And then to obtain endorsement and commitment of fair and care data principles from 100% of the deep sea decade actions by 2028. So as a networking group, we think we're a good platform to work on those agreements. Continuing on the data theme, we have a goal to promote accessibility and discoverability of deep ocean biodiversity data. This doesn't mean that other kinds of data are not being done and important, but this is a place where we felt with the network that we had, if we gave a push here, we could have a real impact. So our goal is to double the amount of deep ocean data that are discoverable and openly accessible online by the end of the UN Ocean Decade, and we recognize OBIS as a critical partner in that. Deep sea science requires an integrated observing system. So the goal here is to promote the use of multi-purpose infrastructure to enhance deep sea observing, monitoring, and knowledge. Targets here that have to do with data or CI are to create and operationalize a functional and fair data clearinghouse for deep ocean observations linked to, and I'm sorry for the acronym soup here, but we do plan to do this in collaboration with Otis. And then to collaborate with the digital twins of the ocean project as well, bringing in deep ocean data into that. And then there are some targets that are less data focused. So this one is not data focused, but I thought it was important to highlight because it really represents a vision for, in the coming decade, having the way science is done globally really change. So this group is committed to training and empowering the next generation of deep ocean professionals. So that's early career researcher support to break down barriers to communication, particularly across sectors like the policy and legislative groups and the scientists developing the data. So that's translating knowledge to the decision makers, working to amplify traditionally underrepresented voices and advocate for and promote traditional and indigenous knowledge. So that's much larger than the CARE principles, but clearly endorsing CARE principles are a part of that. Then here, this is a reference slide where I list some of the additional goals that have been identified by this group. They all have targets as well. So if you are interested in any of that work, I invite you to engage with this group. There's the website there. You have my name here. And that's what I have. Thank you very much.
Thank you. Does anyone have any questions for Karen?
There's a question in the chat from Kristen. Kristen, you can unmute yourself, I believe, if you'd like to ask that verbally. Or
I
if
can you hear me?
yes, yes.
Yeah, I was just wondering, and in part it was I think answered by Karen's further slides afterwards, that ocean floor is included in the deep ocean definition. Is that true?
Yes, and so Cobra is our major partner there. So there's another ExcelNet project that is actually dealing with kind of the hard, the sea floor and subsea floor. So we sort of work together to, represent water column through subsea floor.
Okay, that would be interesting. I mean, we have a lot of geochemistry of the actual ocean floor rocks that have been dredged over the last 50 years. So I'm just wondering how to best connect or make.
I think there's two avenues on more of a larger networking approach. I can get you contact information I'll put in the chat for anyone to see for the Cobra project. If you think your group is ready to work towards or has some of the schema.org implementation, I think we're all looking to feed into Otis through that mechanism. And tomorrow we'll talk a little bit about some of the extensions that we're doing to make this work for deep ocean data. So if you're interested in that conversation, please feel free to contact me directly and we can connect you.
Okay, great.
That way.
Thanks.
Thank you. Now we're going to move on to Kate Rose presenting on CMEX.
All right. You can see my screen and hear me?
Yes.
Okay, great. Yep, good morning. I'm Kate Rose, and I guess I'm going to give a much more sort of granular level perspective on trust and the ocean decades, talking about this single project. So the Coastal and Marine Ecological Classification Standard is, I guess I'm not advancing. There we go. So the Coastal and Marine Ecological Classification Standard, also known as CMEX, it's an authoritative thesaurus for the marine environment. Consists of defined terms, which we refer to as ecological units that describe habitat characteristics. And so these ecological units are organized in spatially scaled hierarchies. They really emulate the interconnected components of ecological systems. And they thereby provide a scheme for organizing data and for mapping and modeling ecosystems. They're not typically used as metadata keywords outside of CMEX users who create these products, but there is growing interest in using them for that. And so CMEX was endorsed by the US Federal Geographic Data Committee in 2012 as the National Ecological Classification Standard. And that involved a rigorous process. It was developed with over several years with the input of over 100 contributors, went through a 120-day public comment period in 2012 prior to its publishing. And where they adjudicated over 700 comments, and we stay current by adopting changes that are proposed to CMEX by the user community in order to keep it scientifically valid and current and useful. And so this community consensus allows us to provide standardization and consistency in the way that data products are produced so that they're comparable across time intervals, which is really important if you're trying to document condition and trends in an ecosystem, and from region to region so we can identify comparable ecosystem conditions across geographies. And so that means that you can have reliable data products that meet regulatory requirements, which is a very valuable thing. And so there's really a transference of trust. So because CMEX is so thoroughly vetted, it's trusted to be a representative of the scientific consensus and encourage wider implementation. And that reinforces the trust in the products and outcomes. Those become more trustworthy. And so up to now, we've been demonstrating that trustworthiness the way that we do in the sciences with a publication. And so we have this FGDC document, which contains the classification, scientific context for it, the guidance for using it, the process to develop it, with a full citation list and a list of references and all that. And we maintain a couple of different websites that sort of focus on different aspects of CMEX, where we can share information with the scientific community. But staying relevant and meeting the needs of the scientific community these days requires a lot more, and we know that. And we already knew that we needed new digital tooling to help us maintain the CMEX vocabulary. But we also know that there are far greater volumes of data that require new processing and analysis techniques. And I think, as Pierre elucidated really well earlier, the Ocean Decade is really sort of outlining and challenging people to meet these interdisciplinary global challenges to help with the UN Sustainable Development Goals. And so CMEX, we were encouraged by one of our partners to apply as a UN Ocean Decade action. And our application is in review with the Ocean Decade Coordination Committee. And what we're presenting and what we're trying to do is to present our work to become more interoperable and to be able to, we meet the endorsement criteria goal that is up there in green right now. We're co-designed and developed by knowledge generators and users in that respect. And we feel like we have a valuable contribution to make to the global community. So I think by upgrading and modernizing CMEX into a digital format will help us to meet these other goals and objectives and challenges. And so when I started out looking into how to do this, I consulted a lot of other resources, but this publication, the 10 Simple Rules, really sums up the process very well. It's very concise and very easy to follow. And so we're probably all aware of the FAIR principles, but there are steps here that are related to each individual principle that are outlined in the document. And so, the goal is to make your resource findable via web identifiers so that they're easily searchable and available to be returned in a digital format, accessibility, via term identifiers, to be able to interoperable. And that's like not just on a technical sense, but also in a knowledge sort of sense. So, going back to the community standard of consensus representation of knowledge. And to then also be reusable so that other people, it can be consumed and used for other purposes other than what we had originally intended as well. So just the very shortcut of how I started on this. We have the CMEX document itself, which again represents the community standards, and so interoperable that way. And I was using Protege software in order to encode all of the terms and definitions into OWL ontology. So that allows us to, craft the definitions and to add all that term metadata that's really important to establish and to convey the trust and to continue, transferring the trust from all of our rigorous scientific discussions and vetting, and make sure that that's captured within the metadata of each term. Also, they're able to provide licensing and the provenance and individual resource reference IRIs. So in order then to make that findable, or we're using GitHub or Git to enforce like version control and documentation, sharing these resources out on a GitHub. This is not quite public yet. I mean, the code itself is not public, but we have the repo established, the GitHub established if people wanted to check that out. That provides us with external user access, and I'm in the process of getting a DOI issued for that. And then also to be able to have these rendered so that we have like these resolvable human readable representations from our from the code. I've issued or added the CMEX OWL to the ESIP marine metadata ontology registry and repository, and also issued W3ID redirects for that, so that those are even more permanent PURLs, so that if that resource has to change locations, those IDs will still work, URLs will still work. And so this gets us to our end goal of being a resource that is then able to be mapped to other vocabularies so that we can perform some semantic harmonization and further strengthen the scientific consensus around like what these terms and definitions actually mean. And it will let us connect and network with other classifications and taxonomies. So CMEX is very comprehensive and deals with the information in multiple domains of the marine environment, but we're very ecologically focused, so we don't get into things like, we don't get down to classifying to species levels. And we have like a lot of our users who do want to map interactions between, say, species and the environment. And so if we could connect with other or provide a resource that people can put together with other classification taxonomies as well, and make that some easier tooling for annotating their data. And I guess we're also now in like a format where we're CDIF and OTIS compatible, and are looking to see what role we can play there. And so that, I think, kind of brings us towards achieving some of like the UN Ocean Decade goals and challenges, so that we are able to contribute to building capacity and generating comprehensive knowledge, hopefully accelerating the generation and use of knowledge and understanding of the ocean, and mostly to be able to strengthen existing and create new partnerships and see where we can fit in and where we can contribute. And that's all I have today. Thank you.
Thanks, Kate. I see your question there, Pierre, but in the interest of time, we're going to move on to Marshall Mall's talk first, and then we'll have a few minutes at the end where you can bring up your question again for Kate.
Hi, thanks. Can you see my screen?
Yes, we can see your screen, Marshall.
Yeah, let me start. I think I will need only maybe 4 or 5 minutes. So talking about ocean data and like semantics, knowledge graphs, ontologies, and vocabularies in ocean data, marine data. I can recall my memory because in my recent work, I have not done anything, I mean, personally relevant to ocean data or marine data. But when I was a postdoc, I still remember I had some really good interactions and discussions with the interns, students, and also researchers in 2 programs, at least 2 programs related to marine data. I believe many of you are familiar with those 2 programs. One is the ODIP. I remember Helen Glaves and Adam Ledbetter even visited RPI. That's a place where I finished my postdoc, and also we had many discussions at EGU and AGU. And I think that's the first chance I came to know how people in the oceanography and the marine science community, they are also working on the relevant topics on ontologies and knowledge graphs. And then the second one, I think, is more technical, Becker demo. Adam is here. So in that time, it's really like an eye-opening chance for me to learn how Adam and Cindy Chandler and a few other researchers, how they were using the so-called faceted search and the Becker demo data portal. I think is still functioning even now. And this also brings a fresh idea of how to deploy semantic technologies in open data, data discovery, and data access in many other data portals and also other research disciplines. But coming back to the general relationship between FAIR principles and semantic technologies, about 2 years ago, I was trying to put all those trends and technologies and the source together. So I spent just like one afternoon trying to do a match between the detailed items in the FAIR principles, and then think about whether the item is like strongly relevant to semantics. So for semantics, I mean some technologies like vocabularies or ontologies, or in other is kind of knowledge graph, and then whether semantics can contribute to the implementation, or in other words, like the real world realization of that item. And this is like just like a personal point of view, but as I say, it seems like the interoperability and reusability, most items, they have a very strong relationship to semantics. But then the findability and the accessibility, since it's a very naive idea, seems they are kind of medium or night relationship to semantics. But still, I think many of them, they are closely relevant. And also, I was teaching knowledge graphs and semantic technologies in the university, and also in my own research in the recent 2 or 3 years, we have done some work, and not exactly in marine and ocean science, but we have done some work with researchers in the field of solid earth science, including mineralogy and also geological data like geological maps, and also mineral species, distribution of mineral species. And then very often we had about questions from other researchers like geologists and mineralogists, and also students who are like the newcomer to this field, how to build a knowledge graph for a certain topic, and then facing the trends in data science, machine learning, and the nowadays natural language models. What can knowledge graph, what can ontologies, like how can they be efficiently deployed in their actual work? I mean, facing like geological mapping, the sharing of geological maps, facing the work of mineralogy, facing the work of the study like the mineral species distribution or the evolution of mineral species, and even the co-evolution between geosphere and the biosphere. How can knowledge graphs, how can these semantic technologies be efficiently deployed in the workflow? So I was trying to answer this question, but then I think it's one day I say, okay, why don't we use like a kind of a structured way to organize our source? Because we are talking about data science and data science applications in those different disciplines. So I discussed with my collaborators, why don't we just use like a data science workflow, as you can see in the diagram in the center of this slide. Let's just follow the steps in this data science workflow from data discovery, collection, data cleansing, and then presentation of the cleaned data set to some exploratory data analysis, and then some machine learning data mining applications. We call them confirmatory data analysis. And then the last is like once we have the derived data set or the results, we also do visualization communication. So myself and my collaborators, we, in the past, I think 1.5 or even 2 years, we try to collect a number of interesting use cases following the steps in this workflow. You can see schema.org, Adam just mentioned them, and then like the data pre-processing or cleansing. I think One Geology has done a really good job developing and deploying vocabularies in the data cleansing work. And then exploratory data analysis, we have also found some examples like they're using visualized graph and then ontology to allocate steps in the R workflow. And then this part, I think students, they are mostly, many of them, they're interested in this part. We found a number of examples, but here I just listed 2 of them. One is how to use knowledge graphs in the patronymic exploration, and another one, at that time, it's called object-based image analysis. And now there's also a very fancy topic, it's called semantic segmentation. I think they are all relevant. And then for the visualization of the data outputs and also the communication, I also found a few examples like a Matclip. They have a way to embed provenance in the output of climate research, and also in the USGCIP, the Global Change Information System. There's also like provenance embedded data portal to present not only the scientific outputs, but also the whole provenance, including the organization, data set, algorithms used to analyze the data set to present all the whole provenance information to the end users and the decision makers. And then in the morning, you have had the talks given by other presenters. So I think from our side as a researcher on the general semantics, for sure we can also include more details about like ODIP, backup demo, and also the ODIS. I think this is a good way to introduce the work to early career scientists and other potential collaborators or students to give them like a quick overview about the big picture and then attract the interest to join the collaboration. And then talking about the ESIP Semantic Technologies Committee, if we have, I don't know, I think many of the audience, they are already very familiar with this committee. This, I think, is one of the long-lasting committees within the ESIP community. And in the past 10 years or even 2 decades, we've seen really good outputs from this committee, including the suite ontology. And also we have many other, we call them spin-off clusters, like the semantic harmonization, the marine data, and the schema.org clusters, and the soil ontologies working clusters. We have a lot of interesting topics happening within this committee, and also the derived topics. So talking about the relationships between this committee and then the marine data and also the United Nations Ocean Decade, for sure we can do a lot of collaboration. We can invite talks on topics of common interest, like how to build vocabularies. I actually met Sam Cox just 2 months ago. Some of you may have read his new article about this 10 simple rules for making a vocabulary fair. Absolutely. I can also invite him to give a talk. And also we can invite people from ODIS and also other ocean open data community to present their work and the progress and the results. And then among all the committees, clusters within ESIP, for sure, we can organize discussions and even like hackathons or small working meetings on focus items. Okay. Yeah. So I think ESIP is a very down-to-earth community, and then from the talks in the morning, I can see this is a very active community on ocean and marine data. Absolutely, I will be happy, and also the whole committee will be happy to collaborate. I will stop it here. Thank you.
Thank you, Marshall. Does anyone have questions for him? Okay. In that case, we will move on. And so we just have a quick slide for discussion. Is there anything else that's happening within ESIP and the Ocean Decade that we haven't talked about, haven't covered? Anything you can think of, anything that should be linked in together? This is sort of a time for anyone to unmute themselves and speak up, or you can also put comments in the notes. Yeah.
Maybe Carolina, just a question to you. So, from the marine data cluster's perspective, there are lots of data initiatives that for sure aren't on the map in terms of Otis or other activities. Sorry to put you on the spot, and I hope your voice is recovered, but do you see a route here to get them present in global systems like Otis? Because then ESIP would have a very strong foothold to say, look, our marine data interests and their overlaps are globally visible via one of the metadata sharing schemes that actually started in ESIP.
Yes. So I think just the bottom line is that, yeah, that was the motivation for these sessions. And yeah, I apologize for my voice. I've been sick, but definitely. And so we're hoping to collect, especially we're inviting people to share in the document, like yeah, other opportunities that where people can connect and get involved and be represented in the Otis system. That's yes. The short answer is yes.
So, but what kind of capacity can we give you in this time, like the tutorials? Because I think Adam, that would be a good place to partner with Science on Schema and say, can we come up with the same sort of training pack, right, to help people do this? We are generating training materials for Otis. Our funder requires that. And by and large, it's aligned to Science on Schema. But again, the closer we can get those specifications, the better. And I think I don't know what mechanism is the right one.
Yeah, I think that, yeah, definitely like know how, but also maybe even opening communication channels, because I did notice, I mean, Otis is, I mean, like Doug laid out that it is, they are curated partnerships. So maybe just like, what are the pathways to become one of those partners?
Mm-hmm. Yeah, we're putting together a getting started guide
Okay.
that we put in our documentation slide. And when we say curated partnership, it's
Yeah.
it's a very low bar. It's basically, are you a legitimate ocean entity, right? Ocean interested entity, and are you serious about it, right? So it's a very low bar to be part of Otis. To be listed as like a trusted data source for the UN or something is a different thing, but that's not of interest to most partners. They just want to be on the map and there. So that's a really low bar. It's nothing to worry about. It's mostly just a quick vetting to make sure that it is an actual organization and is not malicious.
Yeah, that's a good criteria. Yeah, but even just acting as a liaison to, yeah, move people your way, or sharing even that information, even if the bar is low, just, you know, that explicit statement is great. So I think that's what we're trying to do, is just to facilitate those conversations.
Okay, I'll link you to the getting started guide. I mean, it's just on GitHub. We're just drafting it right now, so please excuse the draft.
Great.
But if people are interested in just an early view of that, I'll drop it in the chat.
That's awesome. Yeah, and we'll include it in all of the notes docs.
Maybe it's something that in session 3 tomorrow we can talk about in discussion in potentially breakout rooms for people that have their data sets, don't necessarily want to speak up right now, but tomorrow we can look at it in depth, and people can get ideas on how to really get their organizations to start applying for this.
Yeah, this is perfect.
Kate, do you want to read out your question, or would you like me to read it out?
Oh, no, I'm sorry. I didn't have it wasn't a question really. It was a response to Pierre. I think that, and he was just asking about or noting that, getting out into sort of like the international realm, and there may be, people, or there are some sensitivities as to what classifications are applied, just simply due to political considerations and commerce and things like that. And I think that, we have discussed before in our semantic harmonization clusters, that there's really unlikely to be like one single vocabulary and schema that works for every purpose in every project. But, one of the additional points of, implementing these FAIR principles in the vocabulary is that, so that, at least people who are looking for classification to use can look at what you're presenting, or to look at a classification and understand like the provenance of it, and all of those different and so that you have terms that are well defined, right, and you understand where they come from, and to understand like the focus of them, because that can sometimes be very different, and so that people are able to make a good decision as to which classification scheme that they want to use, right? And so let's say they might want to use certain parts from one scheme and from certain parts of another scheme to sort of bring them together to actually be able to accomplish the goals of their project and describe what they need to describe, right? But we need to just make sure that, that there is that transparency about what those classification schemes represent, so that people can understand and use what's right for them. And so CMEX might not be right for every case, and it probably isn't, so.
Yeah, I mean, but I think that's also where the work that semantic harmonization did with the cryosphere stuff is a really good example of saying, okay, if it's serious and it's not just a sort of science project kind of vocabulary, if there's commitment to maintain it in the long term, and it's of high technical quality, then the task is to make sure that it cross maps to other ontologies, so that you can hop from one to another. It's hard work to do that, but it's really worth it. I mean, we've started a bit of that with the CMEX and ENVO, as you showed. And that sort of thing is what makes things really interoperable. In fact, in the FAIR principles, in the interoperability one for knowledge representation, it's saying that, okay, your vocabulary is fair when it interoperates with other vocabularies. So the user can hop from one to another, knowing that they don't have to create that mapping themselves, because that skill set is very rare still.
Yes, exactly. And I think, as you mentioned, it is really difficult work. And so to make sure that that is sort of persistent, and then it's out there for other people to use. And so that effort doesn't have to be duplicated needlessly. So it's another consideration.
Okay. Yeah. Great. So this is the first of 3 sessions. We will have our next session right after the break. It's titled Presentations and Panel Discussion of Trustworthy Data Networks like Otis for Marine Data in the Ocean Decade. That one will start with a set of presentations and then go into a panel format with discussion and Q&A between the panelists and from the audience to the panel. We hope you will join us there. And also on our third session and final session tomorrow. And so thank you for attending. If you have any questions or comments, whatnot, feel free to drop it in the notes. And we will see you after the break, hopefully. Thank you.